Anytime you cut metal, you must start by figuring out what it is. If you picked it up from the first-year engineering store, it will either be steel, which is ferrous metal, or aluminum, which is non-ferrous. The word ferrous just means that it has iron as one of its main components. Other than the look and feel, the easiest way to figure out if a piece of metal is ferrous or not is to put a magnet on it. If the magnet sticks, then it's ferrous. This is crucial because different tools are used to cut ferrous and non-ferrous metals. The easiest way to cut aluminum sheet metal is with a shear. A shear is essentially a giant pair of metal scissors with a long handle to give you leverage. Line the sheet up with either the straight edge or the miter gauge. Then, line the mark up with the back edge of the shear and bring the handle down to cut the material. When making different types of cuts or cutting thicker materials, use the bandsaw instead of the shear. Using the bandsaw for aluminum will be loud, so make sure to wear hearing protection. If you need a refresher on how to use the bandsaw, check out the section of the tool card video linked here. If making a cut that does not go all the way through your material, stop the saw at the end of the cut and back the piece out once the blade has stopped moving completely. Lastly, cutting metal on the bandsaw will leave sharp burrs all along the edge. To remove these, use a deburring tool. Unlike aluminum, ferrous metals are much harder and can quickly dull cutting teeth, so we need specialized abrasive wheels. To cut things like small steel axles, we have a miniature cutoff wheel. Metal cutoff wheels are made of very small, hard, abrasive grain, like that found on sandpaper. The abrasive grain is compacted and bonded together into a solid wheel. The result, when spun at high speeds, is a flat line of grit that grinds a groove through the metal. When this happens, the high friction heats up iron particles in the steel. They glow red and are pushed out the back. This is completely normal and should be happening. Because of the sparks, it is important to be aware of fire risks. Before cutting, make sure there is not a pile of sawdust in the path of the sparks. Also, your cut parts will be very hot after cutting, so do not touch them until you have allowed them to cool down. The other large potential hazard with cutoff wheels is the wheel itself. Since it's made of many small particles that have been bonded together, there is a risk that the wheel could break apart. This mainly happens when pressure is applied to the side of the disc while it spins. The first safety step is to inspect your setup. Make sure your part is clamped firmly and ensure that your cutting wheel is in good condition. If the cutoff wheel looks damaged, let a lab assistant know and do not use it. Step 2 is to stand off to the side of the cut. If anything goes wrong while cutting, it will happen in plane with the cutting wheel. Make sure you and others stand clear of this area. In addition, double check that you and everyone else in the room are wearing safety glasses. To make the cut, turn on the cutter and press in the safety. These small cutoff wheels don't have very powerful motors, so you will need to go slow. Use the sound to gauge your speed. When the wheel starts up out of contact with the material, it will be spinning very fast. As it is lowered into the material, you can hear the blades slow down, as well as see sparks start to come out. If you press down too hard, the wheel will slow down too much and less sparks will come out. Make sure to use light pressure and let the tool grind the material away. The larger version works just the same. If you need even more control over your cut, or clamping it in the chop saw is impractical, a rotary tool with a metal cutoff wheel can be used in a similar way. Keep in mind that you must avoid twisting or curving the wheel while cutting. Lastly, an angle grinder can be used in a similar fashion. It is important to note that with an angle grinder, there are different wheel options. There are cutting wheels that are designed to experience load on the edge only and should never be twisted while in a cut, as well as grinding wheels that are specifically made to experience a load along a flat face. So, just to recap, start by determining if you are working with steel or aluminum with a magnet. Next, decide which tool to use based on the shape and size of your material. Before you start, take a second to double check your setup. A clean and organized work area is key to staying safe and focused. Line everything up, make sure it is firmly held in place, and make sure that you and everyone around you is wearing proper PPE. Then, slowly make your cut. When you're done cutting, wait for the parts to cool down if you used a cutoff wheel.